Hi, I'm Jill. Today we're going to look at horizontal asymptotes. An asymptote is a line that a function approaches but never quite reaches. An asymptote can be vertical, horizontal, or slant, and the asymptotes in these pictures are shown in green. As you can see, the middle one is horizontal. One place you may see a horizontal asymptote is in a rational function. What's a rational function? It's a quotient of two polynomials. In a rational function, a horizontal asymptote may happen at extremes of x, negative infinity or infinity. When does a horizontal asymptote happen in a rational function? Let's look at some examples. The first case we'll consider is where the degree of the numerator is less than the degree of the denominator. So, for example, that could be x over x squared or 1 over x. In other words, it's some expression with a power of x divided by another expression with a higher power of x. A good example is y equals 1 over x, where the degree of the numerator is 0 and the degree of the denominator is 1. As you can see, as x goes to negative infinity or positive infinity, y goes to 0. Then what happens with a higher degree denominator, say 1 over x squared, or 1 over x to some higher power, or some other number over x to some higher power, or x to some power over x to a higher power? They all go to 0. 1 over x to a power goes to 0 faster as the power gets higher. A constant over x to a power goes to 0. X to a power over x to a power goes to 0 as long as the numerator power is less than the denominator power. Let's look at a complicated case of a polynomial in a numerator divided by a higher degree polynomial in the denominator. I made this as messy as I could. How can we sort this out? We'll multiply both the numerator and the denominator by 1 over x to the power of 4. Any number divided by itself is 1, and multiplying by 1 doesn't change a fraction's value. So by making this move, we're changing the expression's format, but not its value. And what do we get? In the numerator, everything is divided by x or a power of x, so everything goes to 0. In the denominator, everything goes to 0 except that first highest degree term. When you multiply 3x to the fourth by 1 over x to the fourth, you get just 3. Then the function goes to 0 over 3, which is just 0. As you can see, the graph does some fancy stuff near the origin, but as you start going to extremes, the graph starts going to 0. The other case of a horizontal asymptote is where the degree of the numerator equals the degree of the denominator. I made up another messy example. This one for numerator and denominator of equal degrees. Let's go through the same exercise as before, multiplying both numerator and denominator by 1 over x to the fourth. This time, everything drops out except the highest degree terms in the numerator and the denominator. For those terms, only the coefficients are left. So, for example, 6x to the fourth times 1 over x to the fourth is 6. And 3x to the fourth times 1 over x to the fourth is 3. So the result is 6 divided by 3 plus a lot of stuff that you don't need to worry about because it goes to 0. So in this case, as x goes to infinity, y goes to 6 divided by 3, and that's 2. Generally, as x goes to infinity, y goes to the quotient of the coefficients of those two highest degree terms. And that works because the degrees of the numerator and the denominator are the same. And this is what it looks like on a graph. Complicated stuff around the origin, and as x goes to negative infinity or infinity, y goes toward 2. Are there other cases of horizontal asymptotes? What if the degree of the numerator is 1 more than the degree of the denominator? That's a slant asymptote, which is a whole separate topic. And that is covered in a video to which you can find a link in the description below this video. And the takeaway. A rational function has a horizontal asymptote in 2 cases. The first is the one in which the degree of the numerator is less than that of the denominator. In that case, y goes to 0 at extremes of x. The other case is where the degree of the numerator and the degree of the denominator are equal. When that happens, at extremes of x, y goes to a value that's equal to the quotient of the leading coefficients of the numerator and the denominator. If you have questions or comments, please post them. I'll be watching. Thanks.